Welcome to The Deep Dive. Today we're going to dig into something that's, well, really blowing up in software engineering lately. Platform engineering.
That's right. We've waded through quite a bit of material articles, some research, plenty of online discussions, the usual forums where people are hashing this out.
Yeah, lots of debate there.
Definitely. Trying to nail down what is platform engineering. How is it different from, say, DevOps or SRE terms we kind of thought we had figured out? And yeah, why all the buzz now?
So our goal here is really to cut through some of that noise. We want to pull out the core ideas from everything we looked at, shed some light on what platform engineering really is, sort of clarify those relationships with DevOps and SRE, figure out why it's taking off, and I think crucially, what it all means for you, the software engineer listening.
Okay, so let's start unpacking that. Based on the material, the core idea, the definition you see most often is that platform engineering is the discipline, really, of designing and building tool chains and workflows.
Tool chains and workflows. For what purpose?
To enable self-service capabilities for software engineering teams, it's about building something tangible.
Right, not just a concept.
Exactly. It usually takes the form of an integrated product, often called an internal developer platform, or IDP.
IDP. Got it. And what's the mission statement for an IDP?
The big idea is for this IDP to cover the operational stuff, the necessities across the whole application lifecycle. Think of it like a foundation, providing self-service APIs, tools, services, maybe even knowledge bases and support, all aimed at empowering developers.
Okay, and this is where I think a lot of the confusion we saw in the sources comes in. How does this platform engineering thing fit with DevOps and site reliability engineering? People seem to use the terms almost interchangeably sometimes.
Yeah, the sources definitely highlight that confusion. It's a major point of discussion. But what seems to consistently come through is framing DevOps more as a philosophy, maybe a culture or a set of practices.
Like collaboration, automation, CI/CD, infrastructure as code, shortening the feedback loop.
Exactly that. It's about uniting dev and ops. And like you said, some sources really push back on DevOps even being a role or a title.
Right, more of an approach.
Precisely.
Yeah.
Now, compare that to platform engineering. The material presents that more as a concrete strategy or a process, maybe the implementation of those DevOps ideas. It's focused on building the specific platform, the actual tools that let teams do DevOps effectively, especially at scale.
Ah, okay. I remember seeing, I think it was in one of those forum threads, a really neat way to put it. DevOps is maybe developers running their own stuff, but platform engineering is a team building the platform that lets developers run their own stuff easily.
Yeah, that captures it pretty well. Another angle is just thinking of platform engineering as building that central hub, that platform, where all the necessary DevOps tools are integrated and managed.
And the sources also suggested this might be like an evolution, stemming from the problems people ran into and trying to just say, everyone does DevOps, or you build it, you run it everywhere.
That's a key point. Without that enabling platform layer, you often end up with developers, especially senior ones, spending way too much time fighting with infrastructure, becoming shadow ops, I think one source called it.
Yeah, I saw that term, takes away from actually building features.
Exactly.
Yeah.
So platform engineering is seen as the response to that challenge. And just quickly on SRE, because it pops up too, SRE is really about applying software engineering thinking to operations problems.
Focus heavily on reliability, availability, keeping production stable.
Right. Laser focus on production. So while they all work together, the distinction often drawn is platform engineering leans towards enabling developers and making them more efficient via the platform, while SRE is really guarding the gates of production reliability and performance.
Okay, definition down, distinction made.
Yeah.
Ish. But why the surge now? What's fueling all this interest and, the hiring for these roles?
The overwhelming answer from the sources is complexity. Modern software systems, especially with cloud-native architectures, distributed systems, it's just gotten incredibly complex.
Kubernetes, different cloud services, databases, networking, monitoring tools. It's a lot.
It is a lot. And developers are increasingly expected to understand and manage this huge stack of operational tools and concepts, often things far outside their core domain expertise, and frankly, things they don't have time to master.
Which naturally leads to friction, bottlenecks, duplicated work across different teams trying to solve the same infrastructure problems, just general cognitive overload for developers.
Yes, absolutely. That friction is a huge productivity killer. And like we touched on, trying to push you build it, you run it onto everyone without that supporting platform often backfires, creating those DevOps handy patterns where senior engineers end up doing ops work instead product work.
And the IDP, the internal developer platform, is positioned as the way to abstract that complexity away.
That's the core idea. Provide simplified self-service interfaces through this platform, hide the gnarly details underneath. The goal is to lower that mental burden on developers. We'll let them do operational tasks without needing a PhD in Kubernetes networking.
And the sources seem pretty bullish on adoption rates.
Very much so. Some predictions cited suggest 80% or more of large companies will have dedicated platform engineering teams pretty soon, within the next couple of years. That kind of projected growth definitely fuels the current buzz.
Okay, let's make it concrete then. Based on the material, what does a platform engineer actually do? What's the day-to-day look like?
Well, the main job, obviously, is designing, building, and maintaining that internal developer platform itself. That's job one.
Making sure it provides those self-service capabilities you mentioned.
Exactly. So that means building the tools and the workflows for the common things developers need to do. Think provisioning a database or getting some cloud storage, deploying a service, managing environments like setting up a dev space, handling secrets or environment variables.
All without filing a ticket and waiting.
That's the dream. Avoiding ticket ops, as one source nicely put it, get developers what they need quickly and automatically.
Okay, what else falls into the bucket?
Automation is huge. Implementing and optimizing CI/CD pipelines, managing infrastructure as code IAC templates and tooling, automating other routine operational tasks. Security and compliance are also key.
Baked into the platform itself.
Ideally, yes. Building security checks, vulnerability scanning, compliance policies right into the tools and workflows developers use, so it's the easy path, the default path.
Making it easier to do the right thing, essentially.
Precisely. They also need to provide good monitoring and observability tools, making sure developers can easily see logs, metrics, traces to understand how their applications are behaving and troubleshoot when things go wrong.
And they're not just building this in a vacuum, right? They have to talk to developers.
Oh, absolutely critical. The sources really emphasize treating developers as internal customers. You have to gather feedback, understand their pain points, see what's slowing them down, and constantly iterate on the platform to make it better for them.
So a product mindset for an internal tool.
Exactly that. They also often manage some underlying infrastructure, maybe the core Kubernetes clusters, databases, auth systems, networking. But the key is abstracting it, presenting it through the IDP in a usable way, not exposing all the raw complexity.
Plus documentation, right? Showing people how to actually use this platform.
Essential. Good docs, maybe some tutorials, knowledge sharing, and just continuous improvement, keeping the platform up to date, adopting better tools, paying down technical debt. They might also build tools to help developers during incidents, making troubleshooting faster.
Wow, okay. That sounds like a role needing a pretty broad skill set. What did the sources say about the background and skills needed for platform engineering?
It's definitely a mix. You need strong technical chops, but also really good soft skills. On the tech side, coding and scripting are fundamental. Python, Go, Bash come up a lot. Deep expertise in cloud platforms, AWS, Azure, GCP, and container orchestration, mainly Kubernetes, seems pretty standard.
And infrastructure as code tools are a must-have, I'd imagine.
Absolutely. Terraform, Ansible, Puppet are mentioned, but also newer things like Crossplane or Spacelift that integrate more tightly with Kubernetes sometimes. Then you need solid understanding of CI/CD tools, networking basics, Linux admin, and how distributed systems and microservices work.
And the non-technical side.
Communication is huge. You're coordinating between lots of different teams, collaboration. One source even used the word diplomacy, which makes sense. That product mindset we talked about, treating the platform as a product for developers, is vital. And just being adaptable because the tech landscape changes so fast.
Does coming from a DevOps background help?
The material suggests it's a very common and strong foundation. You already have that blend of dev and ops thinking. But platform engineers often need to go deeper on the infrastructure side while really focusing on that developer experience and product angle.
What about formal stuff? Degrees, certs?
A CS degree or similar is pretty typical, but hands-on experience seems paramount. Certifications in cloud platforms, Kubernetes, maybe security or DevOps practices can definitely help, according to the sources we looked at.
You mentioned tools. The sources called out quite a few specific technologies commonly used in this space.
Yeah, there's definitely a growing ecosystem. For building the IDP itself, that developer portal experience, things like Backstage from Spotify or commercial offerings like Covery, Port, Configure8 were mentioned as examples.
And for managing the infrastructure underneath.
Your standard ISC tools are big, Terraform, Ansible, but also tools like Crossplane, which lets you manage cloud resources using Kubernetes APIs, which is kind of an interesting approach.
Kubernetes itself being pretty central.
Oh, yeah. Kubernetes is almost always the underpinning orchestration layer mentioned. Then for CI/CD and automation, you see Argo CD, Argo Workflows, Jenkins, GitHub Actions, the usual suspects, Docker, of course, for containers.
Any tools for, like, helping developers get started faster?
Yes, scaffolding tools, things like Cookie Cutter, Yeoman, or platforms like Humanitech that help generate boilerplate code and configurations for new services based on predefined templates. That fits right into the self-service idea.
And finally, making sure you can see what's going on. Observability.
Right, crucial. So integrating, monitoring, logging, tracing. Tools like Datadog, Grafana, the ELK stack, Elasticsearch, Logstash, Kibana, Sentry for error tracking, those kinds of platforms are frequently part of the stack.
Okay, great. So we've covered what platform engineering is, why it's gaining steam, what the role involves, the skills, the tools. Let's pull it all together. What does this trend, this rise of platform engineering, actually mean for you, the software engineer listening to this?
Fundamentally, the promise, the goal described across all the material, is to make your life easier. It's about reducing friction and reducing that cognitive load.
Taking away the need for every developer to be a deep expert in Kubernetes networking or AWS IAM policies just to deploy their service.
Exactly. It aims to provide you with smoother, self-service ways to do common operational tasks. Deploying code, spinning up a test environment, getting access to a database. Things might currently involve complex steps, manual processes, or waiting for another team.
So the idea is it frees you up, lets you spend more of your brain power and time on what you presumably enjoy more: writing code, solving business problems, building features.
That's absolutely the core value proposition highlighted. And thinking career-wise, the source is definitely positioned platform engineering as a hot, growing field. The demand is high.
And the salaries reflect that.
The salary data we saw suggests that yes, platform engineering roles often command higher average salaries than, say, more traditional DevOps roles. We saw ranges mentioned, well into six figures in the US and strong numbers in Europe too, though obviously it varies a lot by location, experience, company, all the usual factors.
Definitely something noticeable in the data points presented.
Yeah. So if you're an engineer who enjoys building tools that help other engineers, if you like working at that intersection of dev and ops, but with a focus on creating leverage and improving workflows, it seems like a really promising career path with significant impact.
Okay, so to wrap up this deep dive, platform engineering isn't just a rebranding. It looks like a deliberate, focused strategy. It's about building that internal developer platform to make the ideas of DevOps work smoothly in practice for development teams.
Right, by providing self-service, abstracting away the underlying complexity, and ultimately boosting developer experience and efficiency, especially in these complex modern environments.
And just to leave you with something to chew on, a final thought sparked by the material. If platform engineering really succeeds, if developers can mostly self-serve their operational needs through a great platform, does that fundamentally change what it means to be a developer? Does a certain level of operational fluency just become part of the baseline expectation for application developers? Or does it just create a cleaner separation of concerns? Application developers focus on features, platform developers focus on the platform.
An interesting question to watch as this field matures.